Happy morning, dear friends. Here's yours, Dr. Ajanta. Welcome to Demystify with Ajay. Dear friends, today we are going to discuss about simple linear regression. Yeah, it is the first algorithm, comes under supervised learning. But before going on to this algorithm discussion, yes, one among our beloved subscriber just want to get clarified with the intuition behind this traditional and this machine learning programming. So I just give a small explanation about that, and then let me just move on to this machine learning algorithm. Dear friends, machine learning algorithm constitute the foundational framework of contemporary data science and serve as indispensable tool for the analysis and prediction of the data. This algorithm encompasses a broad range of techniques that are fundamental to the comprehension of the principle and applications of machine learning. And today we are here in linear regression, and this linear regression, in spite of its simplicity, serves as a powerful algorithm utilized for the purpose of modeling and the correlations between independent and dependent variable. It is extensively employed in the realm of predictive analytics and forecasting tasks, with variations such as today we are going to discuss about the simple linear regression, and next we are going to have it as like a multiple linear regression, polynomial linear regression. So everything tailored to cater to different scenarios. Now coming towards this machine learning intuition. The exact question is how this machine learning different from the traditional way of problem solving. To answer these questions, let me just take a simple thing. We just want to make a small typical programming problem statement. Specifically, let us just make two variable. Okay, let me just add two variable number. Okay, so we will quite simple. We take any two numbers as input, and then we employ an algorithm that adds them and produce the sum. And here what we just do, yes, taking this two, we would just sum it up, and it just gives the summation. And here, of course, this one a1, a2, or you can just keep it x and y, whatever you want. Yeah, this is what the exact traditional. Okay, so here you are sending the two input, and towards this output you just get the sum, and here it is our function. Okay, so this is this way that very much easy, and hence we didn't require any sample data that taught us the rules of adding two numbers. But imagine a problem statement where I ask you to write the algorithm that can tell the, for an example, for a price of any house based on some information like sizes or number of bedrooms. So many things are there. So, well, no matter how hard one tries, so it is not possible to come up with some specific rules or a common algorithm that can simply by implemented and can predict the price of any known house in existence, unlike this two variable which we just specified. So in such scenario, yes, we can get a lot of data and then use it to learn how to predict the price of house using given future. So here, yes, this is what we just specify as traditional, and for this, let me just have this, we are going towards this machine learning. Kindly just observe, dear friend, here we are just going to have some rules. We have to find the rules that helps us predict the price of any houses. Okay, so here in this functionality, we are just going to provide the X, which is known functionality, known to us. And this is our function, where with this function and with some rules to identify the price with an unknown, that is the testing data. And yes, once we just get, this is also a known to us. See, if we just provide this X, yeah, we would just get the Y. So in such case, this is the exact fundamental. Why machine learning actually here it's different is, see, because of its ability to see a pattern and learn to create a set of rules. So here, if we are just making these rules, we can use to predict outputs for any new unknown. We can make any unknown functionality. Yes, that is what in traditional way of problem solving, and the input are given and using them we produce an output. But here in this machine learning, the input is known and the output is also known. That is, both the things are given, and which we are going to use it as like a training with the sum of rules. And with this, we are just going to identify the unknown factor. So out of this, the rules that relate with this X and Y, yeah, we are just going to identify. So this is the what which we had a traditional function and the machine learning function. Okay, now let me just move on to the exact linear regression. So here we just go, dear friends. So yes, of course, kindly just see here, dear friends. You are able to see a set of business questions across different domain. So domain, the first one, it is retail. How much will be the daily or monthly or yearly sales for a given store for the next 3 years? Or how many car parking spaces should be allocated for a retail stores? And here in coming towards manufacturing, how much will be the product wise manufacturing labor cost? So manufacturing towards retail, how much will be my monthly electricity cost for the next 3 years? Banking, what is the credit score of a customer? Insurance, how many customers will claim the insurance this year? And last but not least, the energy and towards environment, what will be the temperature for the next 5 days? What you are able to see by seeing these questions, these all the categories, yes, you might have guessed it. The presence of the word how much and how many, that implies that the answer for these questions will be a quantitative or continuous number. So the regression is one of the fundamental techniques that will help us to find answer to these types of questions by studying the relationship between the different variables that are relevant to the questions, so that we are trying to answer it now. Okay, now here, of course, what is the exact answer here is, as I have already specified, this is what. So here we are having our variables as like dependent variable and independent variable. So the relationship between the dependent and independent variable is assumed by the model to be roughly linear. So this connection can be stated mathematically as y is equal to mx plus c, or you can also have mx plus b. Okay, so where here this b, it stands for the y-intercept, and this is intercept, and this m, it is the slope of the line, which represents the rate of change of y with respect to this x. The simple linear regression model minimizes the sum of squared difference. Kindly just observe sum of squared difference between the values predicted by the linear equation and the actual value of the dependent variable. So in order to choose the most efficient line. So this procedure is often carried out by applying least square. Okay, so yes, we are just going to see that in next session. And here the simple linear regression model, see, after taking this, we are just going to fit the model to this data. It may be used to understand the relationship between the variables and make prediction, and as well as just give us towards the conclusion. And here we are just going to think about the correlation coefficient. often known as the Person's which runs, that is from -1 to 1, which allows us to use simple linear regression to measure the strength and direction of the relationship between these variables. And the basic assumption of linear regression are the variables have linear connections. So the observations are independent of one another. The errors are homoscedasticity, which we just say, yeah, have a constant variance. And the residuals, which is are all normally distributed. And yes, let I just give you, these are the assumption of linear regression. So yes, dear friends, linear regression is a powerful tool for understanding and predicting the behavior of a variable. However, it needs to meet a few conditions in order to be accurate and dependable solution. The one such thing, it is all about linearity. Yes, the independent and dependent variables have a linear relationship with one another. So this implies that changes in the dependent variable follow those in the independent variables. So in a linear fashion, as like this linear fashion. And next, it is all about independence. So the observation in the data set are independent of each other. So this means that the value of dependent variable for one observation does not depend on the value of a dependent variable for another observation. So it is independent for each. And yeah, next it is all about homoscedasticity. So across all level of independent variable, the variance of error is constant. So if we just make it, these are the exact database, and yes, the error should be like this constant. So this is said to be the homoscedasticity. And if in such a case anything as like this, narrow towards broader, like this, if it is extending, yeah, it is specified as like hetero. So yes, according to the assumption, across all levels of independent variables, the variance of the error, it should be constant here. And of course, as we know, normality we have to find. So the errors in the model are normally distributed. And last but not least, no multicollinearity. Kindly just observe this. No multicollinearity should be there. So there is no high correlation between the independent variables. This indicates that there is little or no correlations between the independent variable. So these are the exact assumption, yes, that has to be followed. That has to be followed for a linear regression model. And dear friends, let me just go towards data, and let me consider a use case where we have collected some average student test grade and to the respective average number of study hours for the test for group of similar students IQ. Okay, so here, so we are just going to follow some step-by-step procedure. So first of all, let me just have the data collection. So here a number of hours studied by the student. So here it is 2, 3, 4, 5 and 6. And what is the score they just got secured in the exams? That is 65, 70, 75, 80 and 85. So here, let me just have the collection of data. Okay. And even though one thing, yes, here it is as like a list, you can just go towards the list. Or if you want to create as like a data frame, then you want to do some functionality, yes, it can also make it. And kindly just observe, to make a data frame, of course, we have to import those pandas. So I have just imported the pandas, and both the exact variable, that is hours studied and exam scores, are being as like two variables, two key and value pair, and I have just created as like a dictionary and formed as a data frame. And yes, dear friends, with this, what we want to know. Yeah, so by using this matplotlib, let me just visualize the exact data. And to see how study hours and exam scores relate to each other. So let me just go for this scatter plot. Okay, and yes, to have a view, a clear view, we are just going with some X labels, Y labels, and with the title. So let me just observe here. So this is what that thing. And kindly observe, dear friends, this exact scatter plot of the relationship between the number of hours of the study and the corresponding test score before visually applying simple linear regression. The data points in the graph shows the distribution of these two variables, allowing a preliminary examination of the potential relationship between this study time and the academic achievement. Fine. So now, what is the next? What is the next? Of course, here we are going to fit this using the value, using this variable. We are just going to fit the model. And kindly observe one thing. I have initially started with this. So y is equal to mx plus b. So this is the one. I'll fit to a model aligned to the data, and here we are using y is equal to mx plus b, and here x would be the study hours, and here m is the line slope, and b is the interception, and of course y is the expected exam score. Dear friend, before making it towards the programming, let I just give you a brief related towards this fitting to this line or fitting to the model. Okay, so now kindly just observe. Here we are having our data, and as I have specified like this, let me just have it. And if a line which we just say this is our model regression line to fit, and here we just specify it as like best fit line. How we can call this as best fit line? Why don't like this? So here we have like this data. Let this become a best fit line, or let this can a best fit line, or let this can a best fit line. Why we are saying this as a best fit line? Because two things we have to see. That is, one, the exact linear of these variables. A second one, and to the main functionality, the difference between these best fit line to the data point. If I just want to predict something here, okay, so here if I just specify this would be my prediction, and exactly this has to be there on to the same best fit line. So instead, here this would be my prediction, and here it is my actual data of a data point. In such a case, the difference between these, we would just specify it as like an error. So one such data, if we just specify, it is as like a loss function of this. And kindly just observe each and every data, the exact errorness has to be calculated, and we have to make the summation of that. And here I just want to specify one thing, dear friends. Actually here, yes, we can have it in positive error terms, or here as like negative error terms would be there. And of course, when we just see on to this errorness, we just specify it as like a loss function, and summation of every error terms we have to specify it is in the manner as like cost function. So now we have to calculate the cost function for this best fit line. So as I have already specified, the error could be positive or negative based on its location from this slope, because of which if we take a simple sum of all errors, it would be 0. So we should square the error to get rid of negatively and then sum the squared error. So that is what formation of this cost function. So now let I just give you again. So here the slope equation, here it is y is equal to mx plus b or c, whatever you can just say. And here of course dear friend, y it is the one we are just going to predict the value for the given x value. And the second important point, m is the change in y which is divided by the change in x. So here we would just specify this m as change in y, yeah, divided by change in x, and yeah, that is m is the slope of the line for the x variable, and it indicates the steepness at which it increases with every unit increases in this x variable value. And next one, of course, it is all about the C or B, which you just specified. Yes, it is the intercept that indicates the location or point on the axis where it intersects. And here towards the intersection. So if I just make it like this, okay. So this exact difference, it is what the intersect. So as when we just take it towards the mx plus b or c, yeah, that exact point, if we just specify, this is what the intercept difference. So this intercept is a constant that represents the variability in y that is not explained by the x. Okay, so it is the value of y when x is 0. Got it, dear friends? Now, let me just make this fitting towards the model. Okay. Now, kindly just observe. Yes, we are having our X data. So, this is what our X data. So, our studied. And we are having our Y data exam score. Okay. So, with this, we just got this scatter line. So, kindly just observe. So, when the exact student studied for 2 hours, okay, he just got 65, and the student 2, 3 hours scored 70, and next to 75, 80, 85. So it's going on. And now what is the one is to check with the model, and if we want to fit towards the model to this a line of data, we need to calculate the m and intercept b. We need to calculate the slope and intercept b. How we are just going to calculate. So here I have just given you the exact equation to calculate the m and b. So let me just apply this onto this functionality. So here, of course, we have the x data 2, 3, 4, 5 and 6. So this is what the hours that is studied. And y, the exam scores, the valuation, that is the marks scored. So here it is 65, 70, 75, 80 and 85. So this x, y, so when I just want to make it, kindly just observe, dear friend, here how many records I have? 1, 2, 3, 4, 5. So my n, that is number of data point, here it is 5. And the next one, when I just do the summation of x, of course, I just get 20. And towards the y point, yes, it is summation of y, which is 70, 75, 65. So here I just get 375. And of course, dear friend, this is the sum of y values. And now let me just calculate the product of x and y. So towards this product, let I just make it 65 and 2, 130, 3 towards 70, it is 210, 75 4 it is 300, 80 and 5 it is 400, 85 and 6 it is 510, and let me just have summation of x and y, that is product of x y. 1 second dear friends, let I just have a calculation. So it is 0 1 2, so actually it is 300 here. Okay, so we just get 1550. And not only this, of course, we have to calculate the x squared, sum of square of x value. Sum of square of x value, of course, we have already x it's here. So let me just have the summation here, 5, 25 and 6 it is 36. So let me just have x square, it is 36, 25, 16, 9 and 4. So we just have 90. So now again I just go back to the exact equation. Kindly observe, m is equal to n into summation of xy and subtraction by the product of summation x and summation of y, and divided by n, summation of squared of x variable minus summation of x the whole square. Kindly just observe this one. So let I just give this equation. So m is equal to n by summation of xy minus summation of x and summation of y. So divided by n summation of x squared minus summation of x the whole square. So let we just have the calculation. So 5 into, we just have 1550 minus 20 into this 375 divided by 5 into, of course, this one square. So 90 the whole square. Okay. Okay, no, this one, it is 90 minus 20 the whole square. Okay, so here what we just have, it is 20, and let I just have minus 7500 and 5 into 90 it is 450, 20 square it is 400. So what we just get, 250. So this is 7750, so 250, and here we just get 50, which is 5. So m is equal to 5. And towards, what about the b? So let I just have the b. So again I just go back. So b is equal to summation of y, that is mean y, minus m into e to the power of, that is summation of x divided by n, and with the m only we are just going to calculate here. So yes, so b here it is 375 minus, of course here we have m also the same 5. Okay, so 5 into 20 divided by 5. So which is equal to 55 we just get. Okay, now after calculating the slope, m is equal to 5 and the y-intercept, what it is, b, which is equal to 55. So let me just make the best fit line that is fitted into this. Yes, of course, here we have 2 as 65, and in such a case we want to know if we just make something as like a prediction. So 2 4 let I just have it, it is 2 3 4, I think so, sorry. Okay, so here, yeah, 2 3 4 5 6. So yes dear friends, 2 3 4 5 6. So these are the exact data we have, and 65 70 75 80 85. So yes, we are able to identify this is the exact linear one. And if in such a case, if I just want to specify, or if let me just have a make a prediction for new data points using this equation, that is y is equal to mx plus b. In such a case, for instance, we can forecast a student exam score as if the exact student studied for 7 hours. studied for 7 hours. So X is equal to 7 hours. What would be my prediction? Y. So here Y is equal to M. Of course, we have the value of M as 5 into this 7. Let me have a prediction. And for the value B, we have 55. So observe what it is. It is 90. And kindly just observe, dear friend. So if we have the exact value, and yes, it is just going to be as like 90. So this is what the exact prediction. And let me just evaluate this in a model. And how I can just say a model is a good model. And dear friends, see, actually, if we are just specifying, yes, we are identifying M here and B here, and towards this linearity, we identified, okay, this would be the exact best fit model. But how good is your model? To evaluate this as a good model, yes, we have to evaluate R squared. We are having some metrics widely used for evaluating this linear model, that is R squared, RMSE and MAE, that is C. Actually, R squared is for goodness of fit. This R squared matrix is the most popular practice of evaluating how well your model fits the data. And R squared value design the total proportion of variance that is in the dependent variable explained by the independent variable. For an example, if I just specify like this, so here R squared, how many it is? Total sum of squared residual, okay, divided by sum of square total. So this is what the exact R squared. And of course, it is the value between 0 to 1. And the value towards 1 indicates, yeah, the better model, which is just fitting. And when coming towards this mean square, of course, dear friends, when you just specify the mean square, yeah, it is 1 by n summation of I, that is 1 to n. And you can just say, yeah, y I data, and it is y hat to the whole square. And for root mean square, it is a root here. See, this is the exact square root of the mean of the squared error. And here this RMSE indicates how close the predicted values are to the actual value. Hence, a lower value, that is, if it is a lower value, yes, that significance that model performs a good. And it is one of the key properties of RMSE, which is that the unit will be the same as that of target value. And when coming towards the one, that is mean absolute error. Dear friends, this is the mean or average of a absolute value of an error. So you can just specify, yes, 1 by n summation of I 1 to n. And here, of course, we are just going to calculate absolute value of yi minus, that is y hat. Okay. So fine, this is what related towards the predicted and to that of actual. Now let me just go towards the evaluation. In order to determine how well our model matches the data, and we can finally analyze the performance using the metrics. So first of all, let me just calculate. And yes, dear friends, by using this, we have predicted with the data points. Yes, with the data points, we have just done for 7 hours, and we just got it as like 55. And yes, when you just go for 7 hours, we just got 90 scores. This is what, okay. And to evaluate, let me just make it towards the evaluation. So kindly just observe, dear friend, the same data here. First of all, let me just make it y is equal to mx plus b, and m the value as 5 and 55 the value of b. Okay, now we are just applying towards the prediction. And to calculate the residual, that is the error, yeah, the exam score, y minus prediction, actual and minus prediction, that is what the residual. And if you want to make the mean of that residual, yes, of course, you have to calculate the mean square error. And yeah, for that we have included the numpy and with the functionality residual to the power of 2, and we are calculate the mean square error. And once of all, for calculating the R squared, yeah, to evaluate the R squared fittingness, so we are calculating the total sum of square, and as I have already specified, yeah, this is what exam score minus mean of exam score the whole square, and it is summing of. Okay, so we are calculating the total sum of squares. And with that, again, we are just going for residual sum of square. So with that only, we can calculate the R squared value. And let me just observe what is it. And kindly just observe, dear friend, the mean square error here, it is 0.0 and the R squared is 1. That is, the R square value is 1 and the mean is 0.0. Yes, which we just specify. Yes, this measurement shows how well the model matches the data. With the number of hours studied accounting for almost 100% of variation in the exam score. Let's look another scenario in which we wish to estimate a house cost depending on its square footage. Okay, so we will use Sklearn toolkit and Python to do this simple linear regression. And dear friend, here we are just going to make use of a class, a linear regression. Okay, so to fit a linear regression model to the data, we use a linear regression class offered by Sklearn linear model. And modeling the relationship between the dependent variable and one or more independent variable using the linear technique, which we just specify the linear regression. That is what we are going to discuss it now. And here when we just make use of this functionality, yes, we are going to make two functionalities. One is a predict function that can be used to create a prediction once the model has been trained using training data via fit model. So of course, dear friends, here we are going to make use of predict function and fit function. Both the models we just make use from linear regression class from Sklearn. Okay, so let me just use this and we observe the prediction now. So kindly just observe, dear friends. Here we are having an example. So house size in square feet and corresponding prices. So if it is 800, if it is 1000, if it is 1200, 1500 and 1800, these are the square feet and corresponding price of the houses. So here just actually we just made it as like yes, 1 lakh, 1,50,000, 1,80,000, 2,10,000 and 2,50,000. So just an approximation we have done. And here what we have just done is to create and fit the model, we have called the class linear regression class, and once with that we are going to fit the model with this house size and the house price as its attributes. And once the model is fit, yeah, we want to predict it. So this is the testing functionality. We want to make the prediction, and let me just execute it and kindly just observe, dear friends. Once among this fit and prediction, our output, let me just make it in a scattered plot. So see here, this is what. And with this functionality, so these are the exact data that we just got from as like an input and towards the output, that is X and Y. And when we just called on to this linear regression, we just got a best fit line, this red line. So the best of prediction. And towards this, it just here we just see that using this linear regression, that is to predict house price based on this property, the scatter plot just shows the relationship between the square footage, or we can just say that the total living area of the house and their corresponding sale price. And here I just want to specify, dear friends, what is the exact difference between these two? That is what the error. That is what the error. And if we just do the summation of these error towards this best fit, yeah, there you can observe the cost function. And of course, we are just going to discuss about the difference of this cost function in our next session. And before going on to that, let me just observe the coefficient and intercept here. And kindly observe, dear friends, here, yes, the line of the best fit estimated using this linear regression technique is, yes, when we just specify the slope, it is 141, and towards the intercept, it is minus 632. And what about the mean squared error? It is 75443037, but when on just moving on to this R squared, kindly just observe it is 97%. Yes, this line of best fit that is estimated using this linear regression technique is superimposed on the data point representing the linear model that aims to capture the relationship between the household size and the objective variable of the house price by 97% of its accuracy. And yes, dear friends, so this is how we have just discussed with the basic intuition behind this linear regression, and with the SK model we have just discussed. Okay, let me just come up with a new explanation of the cost function, that is OLS and gradient descent in next session. And hope, I think so, you like this video, and if you found this video helpful, don't forget to hit the bell button and subscribe to the channel if you not yet done, and turn on notification so you don't miss any of my upcoming content. And drop a comment below as you have done previously. Yes, yeah, it just made me to make you clarify here. Okay, so, and of course, if you have furthermore any questions or suggestion for further topics, and always, as I have already specified, kindly just keep learning and stay curious. Yeah, see you in next video, dear friends. Happy learning.